So, good afternoon again. Sorry that you see me again after the session on sustainability and composite materials. I will share this presentation with Gilles KOOLEN, who is a PhD student at our University of Leuven in Belgium, and who is doing his PhD on flex fiber composites, and who is also working as a technical assistant, let's say, for CELC, but I will come to CELC just in a minute. May I have the first slide? So the title of this presentation is Flax and Hemp Fiber Composites, a Market Reality, the Biobased Solution for the industry, for the composites industry. The first two parts I will present, and the second half of the presentation will be done by Gilles. I will introduce CELC briefly, and then I will try to explain you in a few minutes why flax and hemp fibers are so interesting for being used as reinforcement in composite materials. Then Gilles will try to convince you that there is a lot of different versions of flax and hemp fibers, a lot of different preforms available at this moment compared with, let's say, 10, 15 years ago. We have a multitude of different preforms which can be used and which have been specifically developed for the composite applications. And moreover, Gilles will then explain you or present you a number of exciting applications of flax and hemp fibers in composites. First, CELC, the Confédération Européenne du Lin et Chanvre, so the European Confederation of Flax and Hemp, is an organization, a European-wide organization. It groups more than 10,000 companies out of 14 different European countries, from flax farmers to people weaving and knitting and braiding composites. And CELC is also the organization which takes care of traceability of these flax and hemp fibers through the two let's say, brand names, European Flax and Masters of Linen. Western Europe is the world leader in flax and hemp in quantity. First of all, 80% of all the world's production of flax and hemp fibers is happening in those two, and I don't know whether I can... there is no pointer, I think. Is this a pointer? Oops, sorry. Oops. Yeah, I see no pointer here. But we have 80% of all the flax in the world is produced, and you see the number there. It's in the order of 180,000 tons per year. Western Europe is also the place where the flax can be grown in the best way. We have the right climate, we have all the technology, the know-how, since hundreds, thousands of years even. And we also have this traceability, the respect for the people, but also the traceability of these fibers is hugely important for CELC. Within CELC we have a technical section, which in this technical section representatives of the whole European flax industry is represented, producers, preparers, converters of the fibers. It promotes the matching, and that's very important, the matching of the value chain with the needs, the value chain of flax and hemp fibers, with the needs of the composites and technical industry. We try to harmonize the research on flax and hemp within Europe and even worldwide. And by doing that, we try to position flax and hemp as a real interesting solution, the technical solution for reinforcements, for sustainable reinforcements in composite materials. There is, within the technical section, there is a European Scientific Committee. I will not present each of these people individually. They represent 10 different countries and are coming from academia and are, in fact, representing the ongoing research, ongoing scientific research on flax and hemp in the use in composite materials. One of the products which the technical committee within CELC is realizing is, on one hand, we make technical publications in which we explain why flax and hemp are interesting for composite materials. Very important, since 3-4 years we have developed a template for the technical description of flax and hemp fibers. That's extremely important because we know that the composites industry wants to use reliable data which are measured according to existing standards, ISO or European standards. So we have developed these templates which the flax and hemp fiber producers are now using to describe their products. And finally, we just started this year with a series of leaflets, of booklets, where we will explain some remarkable properties, some specific properties of flax and hemp fibers related to their use in composite materials. The first one, you can find it here in the CELC booth or on the internet, is about moisture sensitivity. It's often said that those natural materials might be a little bit critical when they are used in moisture environments. Well, we explain here that that is not really an issue and that it can be controlled. And in this technical publication, best practice and guidelines publication, we address that issue. Now, second part of my presentation and last part before Gilles takes over is why should we use flax and hemp fibers in composites? Well, first of all, we are a technical product, or we use composites in technical products with requirements which are mostly related to their mechanical performance. And exactly in that mechanical performance, flax and hemp fibers are extremely interesting. To the left side, you see the table where it's indicated that, first of all, flax and hemp are about half the density of glass fibers, are even lighter than carbon fibers, but they have a stiffness, a rigidity, which is almost equal as that of glass fibers. Strength-wise, they are not so good, but fortunately, we all know that most composite applications are first of all designed for stiffness and then only for strength. Now, the right scheme, and unfortunately I don't have a pointer here, but the right scheme expresses the properties, the specific properties, so the density correlated properties of different types of composites, and compares them with the green line, which is aluminium, and the red line, which is steel. And we see immediately that the top line, the dark blue line, is carbon fibers, and carbon fibers have a much higher specific stiffness than the green line aluminium and the red line steel. And that's why basically we use carbon fiber composites in all types of weight critical applications like airplanes, but also cars and bicycles. The yellow line is the line for glass fibers, and we see that glass fibers, even stiffness-wise, can compete with aluminium and certainly with steel, but the difference is not that big anymore. And what is now very important is that flax fibers are in between carbon and glass. So flax fibers, from a specific stiffness point of view, specific stiffness for bending, which is in most of the applications the case, that the magenta, or how you call that color, blue-green-like color, that flax fibers are performing clearly better than glass fibers and almost as well as carbon fibers. There are some other issues, and I will go quickly over it. To the left, you have the vibrational and acoustic damping behavior, and you see the flax fiber bar is at least 3 times higher than the carbon fiber bar. And that's one of the reasons why you see flax fibers used in many sporting goods, like tennis rackets, like bicycles, certainly like skis, where these sporting goods have to vibrate as little as possible in order to be either more comfortable or more controllable. And similarly, for radio wave transparency, there flax fibers also outperform glass fibers. And finally, the environmental footprint. It's clear when you look at the left that flax fibers have, from a CO2 or energy consumption during production point of view, are superior, really superior to glass fibers. They have a factor 5 lower CO2 emission during the production of flax fibers, and an order of 30 times at least, there is a lot of discussion, an order of 30 times at least lower environmental footprint than carbon fibers. Of course, energy consumption or CO2 is only one of the parameters. As we discussed in the previous session, for sustainability, we should look at the whole picture, and at this spider web figure there. And there we see the yellow line is for glass fiber, and the green or green-blue line is for flax fibers, heckled flax fibers. And except for land use, and that is evident, you need a certain amount of area to grow the flax fibers, and for eutrophication, which is also evident for plants. But for all the other parameters, flax fibers are superior, have a smaller environmental impact than glass fibers. This has been recently further evidenced by a very serious study, and CELC has been a pioneer in this. You have heard in the previous session maybe the word PEF. It's not a new polymer. It's the product environmental footprint. It's a LCA methodology which has been harmonized by the European Commission and which is now promoted by the European Commission as a kind of unified method to assess the environmental impact of materials and products. CELC has been one of the very first to do a very thorough PEF study, and here you see the result of it. We don't go into the details. They look at, in total, 4 times 4 is 16 different parameters, and then they give a weight to each of these parameters, and then you end up with a certain number of points, and that allows you to compare flax fibers, for instance, with carbon, with glass fibers, and so on. So, the question is now, in which forms are these fibers, flax and hemp fibers, available, and where are they applied? And I give the floor to Gilles. Oh, there you are.
Okay, thank you very much for the introduction, Professor VERPOEST. So indeed, I will give an overview of the availability of flax preforms. So indeed, as Professor VERPOEST already mentioned, so during the last 10 years there has been a lot of developments going on, and now there are a lot of reinforcements available, and is actually comparable with the reinforcements available for other types of fibers like glass and carbon. So we have a whole pack of dry preforms. We have, of course, non-wovens, which has been used for many years, but also, of course, rovings, weaves, also non-crimp fabrics, and maybe also very well known for the moment are the grid structures, and there you can also hybridize flax fibers with other fibers like carbon, to, for example, use the remarkable properties of flax in combination with the traditional fibers. And then on the other side of the presentation, we also provide, or they're also available, flax fibers in combination already with matrix systems. So both thermoset and thermoplastic matrices are available. So to give a very nice overview of all the different companies who provide these preforms can be found on the Flax and Hemp directory. It's a nice online tool to orient yourself in the value chain of flax and hemp fiber reinforcements. And you can also have the contact details of all these companies. And of course, we are at the trade show. You can also meet them at the Natural Fiber Village, which is just over there. And also very nice, of course, there are many applications coming up and already established on flax and hemp fiber composites. And I will present to you the most recent developments of the CELC members. So actually at the moment already, 5% of all fibers, the world consumption of all fibers is natural fibers. To put it in perspective, is actually more as carbon in terms of volume. But for the moment, these are mainly used in short fiber applications. So these non-wovens. And for long fibers, we are still in the early developers phase, where flax and hemp are demonstrated in a lot of different high-performance applications, ranging from automotive, sporting goods, to wind energy and also construction. And there are also the first examples of serial productions in automotive and sporting goods. But the trend is rising, and we hope to further promote the use of flax and hemp. So this is big news that actually reinforces this story. So recently, in the beginning of April, the BComp has announced that it's completed a financing round of $35 million. To invest in flax fibers or flax and hemp fibers, and these include capital from BMW Ventures, Volvo, Porsche, and Airbus. So these are really big companies that believe in flax fibers and show that they believe in flax fibers. And we hope and we also think that it will really push the use of flax and hemp in the future. Traditionally, and is still today, that automotive parts and interior parts are the main application area. Now also a Jack Innovation Award of, among other, Ecotechnilain, who developed a light non-woven for automotive applications, and which is also already around for I think 2 years now, or 3 years now, is a collaboration with Polestar, where they also use the power ribs in combination with non-wovens in automotive interior panels in the Polestar. And also the use of natural fibers in the Polestar will increase over the following years. And also, as Professor VERPOEST already mentioned, so flax fibers is not only about the sustainability, it's also about properties. And this application really shows that you can have weight reduction in comparison with the glass fiber alternative, a 50% reduction in overall weight and 70% reduction in plastic content, and of course an overall reduction of the CO2 footprint of 60%. So it is not only non-structural parts or interior parts, but there are also structural flax and hemp fiber composites used in the automotive sector. For example, this nice impact structure developed together with BComp, where they reach the same or the right crash performance with a flax fiber alternative, and having the advantage of 50% reduced carbon emission. And also, and that's a very important advantage in sporting goods, that instead of carbon fiber, which splinter and which has very sharp particles, this is not the case for the flax fiber or the natural fiber alternative. So this is also a very interesting advantage in the motorsport sector. So also in marine, so you can really see that flax fibers are used in a lot of different applications. For example, by, among other, Terre de Lin, who now produced, together with IDB Marine, 2 boats of 6.5 and 9 meters, where they use now the flax fiber. And they actually removed the glass fiber alternative from their catalog, so they really want to continue with this product. And they're also selling now already up to 10 boats a year, which starting to reach the serial production aspect. And again, it's not necessarily that you use natural fibers that you reduce on performance. So on this case, there was a moderate weight increase of only 6%. And also very important, and I hear this question many times during this trade show already, so there's also a moderate cost difference in this particular application for the use of flax fibers. Yeah, and I was also very excited to see this application. So this is the first one in the wind energy sector, which is of course very important for the composite industry. So it's not the blades that are built of flax fiber composites, but is the nacelle. It's the part where the energy is created and where the mechanics are located. But again, this is a good way to introduce natural fibers to this market segment, and it's very encouraging to see that flax fibers are also popping up in these sectors. This you can also see on the trade show as the award winner in the sustainability section. So it is a new type of flax product. It's the KRLM compound. It's a flax a PLA compound. What's so special about it is that it's also the production process yields very good surface finish that is also printable. And also the whole theory behind it and the circular approach that they have been using has really been innovative to the sector. And then as final application, and also to reinforce again that flax fibers can be used really in structural applications, is this pedestrian bridge that is delivered, I think, a few weeks ago, where they use flax fibers. There is also another example of an even larger bridge built in the Netherlands. And here in this particular case, they use unidirectional reinforcements which are wrapped around a foam core and then used with vacuum infusion to create the final part. So this is a bit of an overview of all the recent developments, and you can find many more throughout the trade show. And you're also, of course, very welcome to come and visit us in the Natural Fiber Village. And yeah, you can see them in real life and also learn about the other applications of Flax and Hemp. Thank you.
Met tijd voor vragen.
Yeah, I think we have 2 minutes.
It seems that we have 2.5 minutes for questions. So, is there any question? Yes, please.
I have a question about cost.
Cost.
Cost efficiency.
The question was about the cost of the flax fibers. I think I'm not a flax producer, but I think the cost is still somewhat an issue. Of course, flax is a natural material which goes through many treatments, purification, fiber extraction and things like that. So on a kilogram basis, it's somewhat more expensive than glass fibers. It's not as expensive as carbon fibers, but you have to look at the low density. It's about 2 times lighter than glass fibers. So for 1 kilogram of glass fibers, you have 2 times the volume for 1 kilogram of flax fibers. And for strength and stiffness, it's the volume, as you know, Thierry, is the volume which counts. So you have always to think in maybe in not euros per kilogram, but what we are not used to, euros per liter, per volume. That's a more fair comparison for reinforcing fibers. There is a price fluctuation in natural materials. As always, we are a little bit dependent on the season and certainly on the demands on natural fibers for other things like my vest here, which is also a competitive market. But certainly there is a large, we use the number there, 180,000 tons. That's 180 million kilograms of flax fibers which are produced per year. That's a lot of flax fibers, and I think we still have to find enough composite applications to use all those flax fibers. So there is no problem of availability. And what is very nice, as Gilles also explained, we have more and more preforms adapted to the demands of the composites industry. Unidirectional preforms, woven preforms, and things like that. More questions? Sorry? Yeah. Yeah. Then I would like, if you are ready, Gilles. Moisture absorption was the question. Well, we can refer to that leaflet, and you can also find it, Julie, on the website of CELC. We have shown in that leaflet that for indoor applications, where you also have moisture variations, there is basically no problem, neither in terms of strength nor of stiffness. For outdoor applications, which are not immersed into the water, that we did not yet finalize, but for outdoor applications in wind and rain and so on, you have to be a little bit careful, but you have to do that as well for glass fiber polyester. You cannot just leave it naked in the wind and in the rain. So you have to use protective gel coats and things like that. But please look at that best practices guideline booklet and site on the internet where you can find all the detailed information. Okay, I think we have to finish. Gilles, you wanted to add something? No? Yeah, you are closed off anyway. So, thank you, Gilles, and thank you, everybody, and enjoy the show further. Wat een hoesbal.